Session 6.2 Applications of Normal Distributions. Session 6.1 we learn about the standard normal distribution. Standard normal distribution means we will have the population mean equal to 0 and population standard deviation will be equal to 1. This is called the standard normal distribution. So think about it. What is the meaning of non-standard normal distribution? You could guess that my population mean cannot be equal to 0 and or population standard deviation cannot be equal to 1. We call this as non-standard normal distribution. When working with a normal distribution that's non-standard, we will have the value of the x in here. And we will apply the formula, convert the x to the c-score. Okay, remember this c-score formula? We talk about this guy on the chapter 3. When we have the value of the x and we want to convert it to the c-score, you could plug in like this formula. For example, I have the non-standard normal distribution, so I have the population mean in the middle. And we assume that this guy's score cannot be equal to 0. That's called non-standard. And then we have the value of the x in here. So we'll use this formula, convert it to the standard normal distribution. Okay, so standard normal distribution, so we assume the mean in the middle here, that will be equal to 0. And my x, plug into this formula. We could find out the c-score in here. This is called the standard normal distribution. Okay, example. Height in a certain population of the woman follow a normal distribution with population mean equal to 64 inch and standard deviation equal to 3 inch. A randomly select woman has a height of x equal to 67 inch. Find and interpret the c-score of this value. Okay, first, population mean equal to 64 inch. This is not equal to 0. And standard deviation equal to 3. This is not equal to 1. So we know we have a non-standard normal distribution. Now, a randomly select a woman. We only pick one woman. Okay, so you could think about the sample size that will be equal to 1. Okay, n equal to 1 in here. And her height is 67 inch. Find and interpret the c-score of this value. So we have the x in here. And we have a non-standard normal distribution. We want to convert it to the c-score. Okay, so I should have the picture like this. We have the mean in the middle, and then I have the x, 67. And I want to convert it, becomes z equal to 0 here. And I need to find out what is the c-score equal to when your x equal to 67. So plug into this formula. Okay, what do you guys get? That will be equal to 1. So we know that we have the c-score equal to 1. Okay, c-score equal to 1. And we are not done yet. We need to interpret the c-score. So what does that mean when c-score equal to 1? We could say that a height of 67 inch is 1 standard deviation above the mean height of 64 inch. Okay, 67 talking about the x, and this is a 1 standard deviation above. And this is 1 standard deviation above the mean height of the 64 inch. Okay, I want you guys try to work the part B here. Another randomly select woman has a height of x 63 inch. Find and interpret the z-score of this value. So my picture is going to be look like this. In the middle, there will be the population mean, 63 inch, less than the mean. So somewhere like here. Okay, now use this formula. You should get negative 0.33. Okay, negative 0.33. Okay, make sure you interpret the z-score here. A height of 63 inch is 0.33 standard deviation below the mean height of 64 inch. Okay, make sure you don't put negative in here. Negative, means below the population mean. Okay, so just say 0.33 standard deviation below here just means like the negative, the mean height of 64 inch. Okay, so if they given the x, we could find out the z-score. Why now I want to do another way around. How about if I give you guys the z-score, can you figure out what is your x in here? We'll be using the same formula here. Okay, we are looking for the x. So in this formula, I'll be multiply the standard deviation for both sides. Okay, multiply the standard deviation here, multiply the standard deviation. So I simplify it. And then I'm gonna add the population mean for both sides. So this is gonna be the new formula. If they given the z-score, you should be able to find out the x. Okay, look at this example. Height in a group of men are normally distributed with the mean 69 inch and the standard deviation is going to be equal to 3 inch. Find the height whose z-score is 1. Interpret the result. This time, they want to find the height, so it means like they are looking for the x in here, when the z-score is going to be equal to 1. So plug into this formula. You could get 72, okay, 72 inch. Make sure you do the multiplication before you add up the 69 in here. Okay, now interpret the result. So a man 72 inch tall has a height 1 standard deviation above the mean. Again, above means like this is going to be positive z-score. Okay, try the puppy. Okay, same formula here. Plug it in. And this time your z-score is going to be negative 2. Okay, interpret the result. A man 63 inch tall has a height 2 standard deviation below the mean. Okay, section 6.1, we learned that when they given the z-score, you know how to find the area, right? We're gonna use the normal CDF, the lower value and the upper value. Okay, again, lower value and upper value, this is talking about cumulative from the left to the right. Or they given the area. Then you need to figure out what is the z-score. So we'll be using the inverse norm. Okay, inverse norm. So this time, section 6.2, we're gonna given the x, and then you want to find out the area. You can use the previous example when you know about the x. You can use the formula, find out the z-score, then use the same way from here. Or, since we're using the calculator, we could follow the procedures like here. Using your calculator, go to second VAS, normal CDF again. Okay, the idea is really similar to the section 6.1. You'll be using the lower value to the upper value, okay, just like the z-score in here. Make sure you're gonna write down your mean and the standard deviation, because when we have the x, that means that we are working on the non-standard normal distribution. So we don't know about the mean, we don't know about the standard deviation. Okay, for the next one here, we're gonna talk about it after the example. Okay, example 3. Height in a certain population of the women follow a normal distribution with the mean 64 inch and a standard deviation equal to 3 inch. Again, we have a mean not equal to 0, standard deviation not equal to 1. So you know you have non-standard normal distribution. Find the probability that a randomly select woman has a height less than 67 inch. So we are looking for the probability, okay? Means like we are looking for the area that a randomly select woman. So my sample size, my n, that will be equal to 1. We only pick one woman and her height is less than 67 inch. So we have the picture like here, normal distribution with the mean in the middle, x equal to 67 inch. And again, they want to find the probability, means they are looking for the area. Okay, think about it. Which part of the area we are looking for? Are we looking for the area to the left, or we're looking the area to the right? It should be the area to the left, right? Because they say less than 67 inch. So this is what we're looking for. Okay, so they given the x and you want to find out the area. So we'll be using normal CDF, all right? Normal CDF. Okay, so we have calculator, second VAS, normal CDF. That'll be number 2 here. We are looking the area to the left. So think about it. What is the lower value in here? Lower value. That will be -1. Make sure you use the negative here below the 3. Don't use the minus, okay? And then the y, use the double y. Okay, don't use the green color y in here. Use the comma with the double y here. So I have a second comma. You're gonna see the y, 99, comma. This is gonna be my lower value. This is means like -1 times 10 to the power of 99, which is really small number. Upper value, that will be the 67, comma. And we need to write down the mean. My mean is going to be 64, comma. And my standard deviation, that will be equal to 3. Okay, close. Enter. So you're going to see that's a 0.8413. For the area, we always want it to the 4 decimal space. Okay, 4 decimal space. So it makes sense, right? The total area is about 1. And then the area from here, this part is greater than half. It has to be greater than 0.5, right? So that's a reasonable value that we got the area equal to 0.8413. Okay, so we're looking for the x less than 67. Write it down here. Lower value, upper value, the mean, and the standard deviation. And we got 0.8413. Okay, B. Find the probability that a randomly select woman has the height more than 70 inch. I want you guys try to do it by yourself. Sketch the picture, which part of the area you are looking for. And think about it. Are you using normal CDF or using the inverse norm? Okay, so we have x equal to 70 inch, so somewhere like here. And we are looking for the area because they're looking for the probability, right? More than, so we are looking for the area to the right this time. So we have a x greater than 70, okay? Area to the right. And again, this time the lower value becomes 70. Okay, 70 to positive 1e99. And then the mean and then standard deviation. Okay, one more time, make sure the lower value and upper value, you always look at it from the left to the right. Okay, from the left to the right. On the left hand side, that will be your lower value. Right hand side here, that will be your upper value. Use your calculator. You should get 0.0228. Okay, C. Find the probability that a randomly select woman has height between 61 and 67 inch. So try to do it by yourself. Sketch the picture, highlight the area, which part of the area you're looking for, and show me all your work. Okay, we are looking for the area from 61 to 67, right? In between. So we are looking for the area in between this part here. Okay, so my x in between 61 and 67. So again, using the normal CDF, lower value from the left to the right. So 61 is going to be your lower value. 67, that will be your upper value. Use the calculator. You should get 0.6827. Okay, 0.6827. Okay, number 4. A study report that the length of pregnancy from conception to birth is approximately normally distributed, with the mean 272 days and the standard deviation equal to 9 days. So you know the mean not equal to 0, standard deviation not equal to 1. And this is a normally distribution. So we have the non-standard normal distribution. What proportion of pregnancy lasts longer than 280 days? So we are looking for the probability. We are looking for the area that lasts longer than 280 days. So we have the picture like this. In the middle, that will be the mean 272 and longer than 280 days. Okay. So we are looking for the area to the right, right? Because the longer than. And then we will be using normal CDF. The lower value is 280, upper value positive 1e99. And then the mean and the standard deviation. You should get 0.1870. Okay, try the puppy. Okay, pregnancy is considered full term if it lasts between 252 days and 298 days. What proportion of the pregnancy is full term? So this time we're looking for the area in between, right? In between 252 to 298. And then we are looking for normal CDF again. Lower value to the upper value. Mean and the standard deviation. So you should get 0.9849. For the homework and also for the exam, please give me this picture, the picture like this, and also I need you guys to show me your work. Okay, you could skip like the X in here, but I need to see normal CDF, what value you plug it in, what is your final answer. Okay, same idea for this guy also. Okay, on homework and also the midterm, I need to see all your work in here. We have the session 6.1 for number 1, number 2, and we just have the number 3, we given the x, and we want to find out the area. So now we are looking for, given the area, we want to find out what is the x. Same idea with the number 2 here. Okay, given the area, section 6.1, we're looking for the z-score. This time we want to find out the x. So you could guess will be the same thing, we'll be using the inverse norm. Okay, inverse norm. And then find out the area from the left, the mean and the standard deviation. Okay, some calculator, the specific to the left, in the middle, or to the right. But most of the calculator will ask for the area from the left. If your calculator allow you using the middle or to the right, write it down on the exam also. Okay, otherwise I would expect you using the area from the left all the time. Okay, number 5. Mensa is an organization whose membership is limited to the people whose IQ is in the top 2% of the population. Assume that scores on an IQ test are normally distributed with the mean equal to 100 and the standard deviation equal to 15. What is the minimum score need to qualify for the membership in Mensa? So we have the normal distribution again, and we know this is a non-standard one. So first, they're looking for the minimum score. Think about it, what they're looking for. Are they looking for the z-score? Are they looking for the value of the x? Or they looking for the probability, the area? Every time when we're working on the non-standard normal distribution, we seldomly talking about the z-score. So either you're looking for the area or the value of the x. Do they mention anything about probability, proportion, or area here? No, right? We are looking for the minimum score to qualify. So we are looking for the x in here. So draw the picture. We have the mean and we have the standard deviation. So we are looking for the x. So they're given the area. So look at the questions again here. Whose IQ score is in the top 2% of the population? Okay, 2% of the population. So means like the area to the right here, that would be 2%, which is going to be 0.02. And you're looking for the x in here. But before that, since they given the area to the right, can you guys figure out what is the area from the left? How can you find out what's the area from the left? The total area under the curve is 1, right? Total area under the curve is 1. So we know this is a 0.02. You could subtract from 1, figure out that will be 0.98 to the left. Okay, area to the left is going to be 0.98. Okay, so we are looking for the x in here. Okay, x greater than something, that will be equal to 0.02. So we'll be using the inverse norm, area to the left, which is 0.98, the mean, and the standard deviation. So use the calculator. Second, VAS, number 3, inverse norm, plug in this number. You should get 130.81. Okay, this is the IQ score. This is the minimum IQ score need to qualify for the membership. But then IQ score is always like whole number. So we're gonna want it. This is means about 131. Okay, x is equal to 131. Okay, B, find the first quartile. Okay, first quartile, the Q1 here. So remember what is a quartile? Quartile means we're gonna divide the data set into 4 parts. Okay, we're gonna divide it into 4 equal parts. So each part is gonna be about 25%. Okay, so we are looking for the Q1. Q1 here means 25% to the left. So they given the area and they want you to find out the x in here. Okay, x represent your Q1 in here. Okay, inverse norm, area from the left, the mean, and the standard deviation. So you should get 89.88. Again, this is talking about the IQ score, so it has to be the whole number. So that will be 90. Okay, Q1 is 90. Okay, C, find the third quartile, the Q3. So first think about it. How many percent is going to be on your left here when this is a Q3? That will be 75% to the left, right? 75%, which is going to be 0.75. Now they given the area and they want you guys find out the Q3, means like your x in here. So again, we'll be using the inverse norm. So x less than something, that will be 0.75, area to the left. Using the inverse norm, area to the left, the mean, and the standard deviation. Use the calculator. You're gonna get 110.11. Okay, so this is gonna be your Q3. So 1 to the whole number, that'll be 110. Last one, find the probability that a randomly select adult has an IQ between 90 and 110. What we are looking for? Are we looking for the C-score? We're looking for the X, or we're looking for the area? We are looking for the area, right? Since they're finding the probability. Okay, probability means like the area. So the IQ between 90 and 110. Okay, find the area in between. So this time they given the X, they want you guys find out the area. Which one you're gonna use? Are you using the normal CDF or using the inverse norm? That would be the normal CDF, right? Normal CDF. So lower value will be 90, upper value is gonna be 110. Okay, the mean and the standard deviation. So use the calculator, you're gonna get 0.4950. So this is about like 50%, and it makes sense, right? Because we're finding that Q1 was 90, Q3 is about like 110. Right? This is a Q1, this is a Q3, so the area in between should be about like 50%. And this number is really close to the 50% here also. That's it for the session 6.2.